All right, what's going on? We're going to walk through the review from today. So tomorrow, remember your properties quiz. I'll send you guys the front page here. Your front page is going to look exactly like this one, okay? Except this bottom one here is actually going to have three properties, not two. So the three properties, remember, we talked about for isosceles trapezoids. The legs are equal, the two non-parallel sides. Um, the base angles are equal and the diagonals are equal. So I'll make sure we add that on and I'll send you a copy of that and remind. All right, so working through the other questions. They're going to be a back page of some of these questions tomorrow. So take a look at number one here. We know that it says rectangle, but it's obviously, it should be listed as parallelogram. The angles are not 90 degrees. So what we do know here, though, is that this angle ABC is 75. The opposite angle, where D is here, is also 75. So if angle 1 is 37, we just do the difference and get an answer of, man, it's gone. Weird. 38. So 38 should be the answer to this one. For number 2, okay, we want to figure out the measure of x and then figure out what y is. So the first thing we need to do is talk about the angles inside this pentagon, this five-sided figure. So remember the formula is 180 n minus 2. Here n is going to be 5. So 180 times 3 is 540. And then we're going to create an equation where we say that 540 is equal to the sum of 96, 142, 70, 12x, and 20x minus 24. We can combine like terms over here and get 284. So that's 96, 142, 70, and then negative 24 plus 32x. Move that 284 over to get 256, and then divide it by 32 to get 8. So now that we know this is 8, we can do 12 times 8, which is 96. So that's the measure of this first angle. And then 20 times 8 minus 24 is 136. And since this angle, the exterior angle here is supplementary, we would know that this is 44. And then if y plus 10 is 44, y is going to be 34. For number 3, we're doing the measures of one interior and one exterior angle. Remember, if it's a regular octagon, that means that all the angles and sides are going to be equal. And we know that there are 8 sides. So in our formula, we're going to talk about n is going to be 8. Remember, one interior angle follows the formula 180 n minus 2. We're going to plug 8 in. And if we want to get the measure of one angle, we're going to divide by the number of sides or angles, which is 8. So 180 times essentially 6, right? 8 minus 2, and then divided by 8 is 135. For the exterior angle, remember the magic number is 360, and we divide that by 8 here to end up with an answer of 45, and that's the measure of one exterior angle. Okay, so it's just what's the sum, and then divide that by the number of angles. Number 4 below, if this angle is 48, the key thing is that we know it's a rhombus. So remember the diagonal here is going to bisect the angles. So these two angles ABD and CBD are equal. So that makes this angle 48. The whole thing is 96. The angle next door to it, DAB, is supplementary. So we should get an answer of 84 for angle A there. For number 5, it's a rectangle. Okay, the diagonals, you remember, are going to be congruent. All right, so we can make an equation where 12x minus 32 is equal to 5x plus 17. We'll subtract the 5x and add the 32 to both sides to end up with 7x equals 49. Divide out by 7 to get 7 for the value of x. And since we're looking for AC, we're going to plug 7 in for x. 12 times 7 minus 32 is 84 minus 32, which gives us 52 for our length. So that's number 5. Number 6, okay, remember trapezoids, these two same side interior angles, if you guys remember, are supplementary. Add to 180. So we'll make our equation. We'll combine like terms. We can move that 9 over and then divide out by 19 to end up with an answer of 9. And then for measure of angle A, we're just going to take 6x and plug the 9 in and get 54. If you remember, y is the mid-segment, so this line is the average of these bases. So 16 y plus 1 is equal to the sum of the top and the bottom, and then divided by 2. Okay, so options, divide this stuff here by 2. So this term, this polynomial by 2. Or we could cross multiply and get 32y plus 2, and then 30y plus 7. We can combine like terms, which we did on the right, and then we're going to just minus the 30y and move over the 2 to get 2y equal to 5. So y is going to either equal 5.2 or 2.5 or 5 over 2, your choice, but that's going to be the answer for part B. For number 7, remember this is a parallelogram, so the diagonals are going to bisect each other. So our first equation we can make is that 5x is equal to 3y plus 4, or 4x equals 8. So here we're just going to subtract the 3x, divide by 2, or we could just do the 4x equals 8 and divide by 4. But you should get 2 either way. In a rhombus, please remember the diagonals are perpendicular. So we get a right triangle being formed here. And that means that these two angles have to add to 90, or we can combine them with the 90 to get 180. I'm going to choose to do this one, but if you want to do plus 9 equals 180, go ahead. We'll end up getting 9x minus 18 is eventually equal to 9x is equal to 108. We'll divide both sides by 9 to get an answer of 12 for x. Now, there's some people who also took a look at this, and they knew that if this angle is 2x minus 13, so are these 4. And if this is 7x minus 5, so are these 4. So they did like 4 times 7x minus 5 plus 4 times this is equal to 360. Or they kind of just did like this, and these two make 180. So they did 2 of these and 2 of these. So there's really a bunch of ways to get what x is, but you should get 12 however way you choose to do it. In C, we're changing this x to 5x minus 12. Otherwise, we'll get a negative answer. So for this question, if these are equal, we'll make our equation. We'll move the 3x over first. We'll add the 12, and then we can divide by 2 to get 11. And the same thing's happening over here for D. Remember that these angles are equal, and we're forming a right triangle here. So we can just do, they add to 90, and then combine like terms, and we should get 15 for an answer. On the last page here for number 8, we want to prove that a parallelogram is a rectangle. So remember, for rectangles, which is sufficient? It would be choice A, the diagonals are equal. In order for the diagonals to be perpendicular, this would be a rhombus for number B. And opposite sides are congruent, would turn this into a parallelogram. So that could be any parallelogram, not necessarily a rectangle. And if the adjacent sides, the sides that are next to each other, are congruent, that is also another characteristic of the rhombus. So just be careful when we do this. All right. For number 9, if the diagonals are perpendicular, they bisect each other, and here's the key, they're not equal. So if they're not equal, it can't be a square, and it can't be a rectangle. So it has to be a rhombus for choice number 9. And 10, if it's a square, remember it has to be a rectangle and a rhombus. So opposite sides and angles being congruent would just make it a parallelogram. It could be any parallelogram, so that's not enough. If the sides and angles are congruent, right, sides are congruent and angles, that would be a square. Because if all the angles are equal, that makes them 90. If the diagonals are congruent, that could be a rectangle, and actually it could be an isosceles trapezoid. All right, and if they bisect each other and are perpendicular, that's a rhombus. So even if we're not sure, we can actually just process of elimination, figure out the best choice. But we want to choose B here for sides and angles congruent. All right, diagonals, perpendicular, once again, not equal. So as soon as we know they're not congruent, that rules out isosceles trapezoid, square, and rectangle. So we're definitely talking about a rhombus again. And which of these diagonals is always congruent? There's 3. There's a square, which is not a choice, right? There's a isosceles trapezoid, which is not a choice. And the last one is a rectangle. For number 12, we are going with which of these is true, pretty much. We'll just check them off. So parallelogram. The diagonals bisect each other? Yes, they do. They are not congruent. They're not perpendicular and they don't bisect the angle, so just that one choice. For a rectangle, it is a parallelogram, so this is going to be true. They are congruent. They're not perpendicular and they don't bisect the angles. A rhombus does bisect because it's a parallelogram. They are not congruent though, so we don't check this one. They are perpendicular and they do bisect the angles. A square, remember, is a rectangle and a rhombus, so all boxes get checked. Okay? A trapezoid, none of these get checked. Dennis doesn't do any of those. Okay? The diagonals don't do anything special in a trapezoid, but in an isosceles trapezoid, not a parallelogram, so this is not true. They don't bisect. They are, however, congruent. They don't make 90 degrees and they don't bisect the angles. So this is your chart for the diagonals of our quadrilaterals. That's it, guys. So we'll see you guys tomorrow. If for some reason you don't feel ready for the test tomorrow, make sure you see me in the morning or shoot me a message and remind. And I can definitely work with you guys to make sure that you are more prepared to take this if need be. Otherwise, I will see you guys ready tomorrow for a short properties quiz. Have a good one, guys.